In this video, we are going to evaluate indefinite integrals involving simple trigonometric functions. Now, we are going to be focusing on the indefinite integral for a sine and a cosine. Now, for the function f of x equals the cosine of x, the integral of the cosine of x dx is sine of x plus c. Now let's think about why. If we think about going backwards and what we know about the integral being the antiderivative, the derivative of a sine is a cosine. Let's think about this one. For the function f of x being the sine of x, the integral of the sine of x is negative cosine. Now, why is that? Well, the derivative of a cosine is negative sine, so we need that negative there to reverse that. So that's the good one to remember. Make sure that when you reverse a sine, when you integrate a sine, it is negative cosine plus c. So let's look at an example. So in this example, we are going to evaluate the indefinite integral of 5 times the cosine of x plus 2. Now, to do that, let's look at each piece individually. The integral of a cosine we just talked about is a sine, but don't forget that 5. The integral of a constant, we know we just have to put on an x. You can think of an x to the 0 there if you want to remember your power rules. But we get 5 times the sine of x plus 2x plus c. Don't you forget your plus c. Now we can make this look a little better. Customarily, you don't usually have to put these parentheses there. So if you just wanted to write it as 5 sine of x plus 2x plus c, that's good too. Let's do another one. This time, we are evaluating the indefinite integral negative 2 sine of x plus 7. Now remember, sine goes backwards and becomes a negative cosine when we are integrating it. So that negative there, we have to think about the fact that, okay, if that negative was there, then normally when we have a negative cosine, it's going to become a positive 2 cosine of x plus 7x. Don't forget your plus c. So that's a little bit about how we evaluate indefinite integrals involving simple trig functions. Thank you so much for watching. You have a good day.